Okay, so to solve this question for T1 and T2, we should start by drawing a free body diagram of the hanging mass. The hanging mass of the red object. It's hanging from a string that I labeled T3, and it is on the plane of Earth, so there's a force due to gravity. And this force due to gravity, so it would be our T3. Because it's in equilibrium, the forces in the y direction cancel out. So T3 is up, Fy is down, Fg is down, equals 0. So the tension in the third rope is equal to the force of gravity on the hanging mass. The force of gravity is mg, so that gives us 60 newtons. So now we know T3. Now to find T1 and T2, we need to draw a free body diagram of all the forces acting on the knot. So here's the knot here. We've got T1 up and to the left, T2 up and to the right, and T3 straight down to the center of the earth. T1, T2, T3, and compared to the horizontal, T1 is 30 degrees above, T2 is 45 degrees above. So now, because it's in equilibrium, the sum of the forces in the x direction equals 0. T1 has a component in the x direction of T1 cos theta, cos 30. T2 has an x component of T2 cos 45. That equals 0. In the y direction, they're also balanced. So T1 sine 30 plus T2 sine 45 minus our 60 Newton T3 force is equal to 0. So now the physics is over and the algebra begins. I have two equations and two unknowns. So I'm going to solve for T1 in the first equation. So from here, so T1 will equal T2 cos 45 divided by cos 30. I'm going to take that and substitute it back in for T1 in the second equation. So then T2 cosine of 45 divided by the cosine of 30 times the sine of 30 plus T2 sine of 45. I'm going to go ahead and add 60 to both sides. So then T2 will equal cos 45 sine 30 divided by the cosine of 30 plus the sine 45. That'll equal 60. Okay, so then T2 will equal .7 newtons. Substitute this back in. T1 is equal to T2 times the cosine of 45 divided by the cosine of 30. Then T1 is equal to 53.7 cosine of 45 divided by the cosine of 30. You get 43.8 newtons.